right, section 12.2 is chords and arcs. So within a circle, we have these things called chords and arcs. A chord just has to have two endpoints on the circle, and the segment is drawn between those two endpoints. So technically, a diameter is a chord. Okay? So you need to remember that. An arc is just a piece of the circle. We've done this before because we found arc lengths where we took a fraction of the circle times the circumference. So we've done arcs before. It's just a portion of the circle. And then we have central angles. These are angles that have their vertex in the center of the circle. And they kind of create a slice of pizza, if you will. All right, so theorem 4. If you have a circle or you have a pair or more of congruent circles, they have three different properties that we can have. Number one, congruent central angles have congruent chords. So if you have a circle, let's just draw a circle down here. You have a circle, and you have a central angle here, and you have a central angle here, and these are both congruent. Then there are chords that run across here, and they are congruent. Okay, so that's number one. Number two, congruent chords have congruent arcs. So let's say you have this circle. You have a chord here, and you have a chord here, and these are both congruent. Then that means the arcs that they make out here are congruent. And then part three, if you have congruent arcs, then you have congruent central angles. So it's actually backwards of part one. So if you have an arc created out there and an arc created out here, and they're congruent, then that means these angles in here are congruent. Okay? Lots of problems that come out of this. All right. Theorem number 5. Same deal. Within a circle or in congruent circles. Chords that are equidistant from the center are congruent. So if we draw a picture for this, you have two chords, and here's the center of the circle. So these distances have to be perpendicular also. But if their distance from the center to the chord is the same on both sides, then those chords are both congruent. Okay? And then this one is just backwards. Okay, so we'll put converse here. So if you have congruent chords, then they have to be the same distance from the center of the circle. Okay, so we want the value of A over here in this circle. That's the length of this chord that goes to R, whatever the letter is up here to R. Okay, if you look, this is the center of the circle. It is 9 from the center of the circle to either chord. So that means that this chord has to be A as well. Okay, and if you see these marks, that means those little sections are congruent. So if this one's 12.5, this one is 12.5. And that means A has to be 25 because it's those two pieces added together. Alright, some theorems to run through, and you may have to pause these to get them written down. First one, in a circle, a diameter that is perpendicular to a chord bisects the chord and its arcs. So if you have a diameter that's perpendicular to a chord, it automatically cuts it in half, and it cuts the arcs in half. Number 7, in a circle, a diameter that bisects a chord, and the other chord is not a diameter, then it's perpendicular to a chord. So if you have a diameter in a chord and they're perpendicular at all, there is a bisected chord that is happening. And then number 8, in a circle, the perpendicular bisector of a chord contains the center of the circle, so it has a diameter. So the perpendicular bisector here would have to be a diameter. Okay, so all three of these are basically saying the same thing. If you have a diameter and the chord and the diameter are perpendicular, then the chord is bisected. All right, so let's use this. Okay, LM is a chord. KN is perpendicular to LM, so that means that it cuts it in half. So instead of that being 14, it would be 7 and 7. And then we want to find R, that's a radius. That is a right triangle over here. So we could do Pythagorean theorem because it's a right triangle. So we'll do 3 squared plus 7 squared equals R squared. And we'll do some math here. And I get square root of 58 when I first do this. But then it says to the nearest tenth, so 7.6 centimeters for your radius. Okay? Lots of Pythagorean theorem here. Alright, last one. Same deal, right? There's a chord, there's this line, and if you look, BC actually cuts the chord in half because it's 11 on both sides, so that means this has to be perpendicular. So we have a right triangle in there. So we can set up for Pythagorean theorem. So we'll do 11 squared plus y squared this time equals 15 squared. Make sure that you get your Pythagorean theorem set up correctly. Alright, so you do your Pythagorean theorem, and I initially get 2 root 26, but it says to the nearest tenth, so that would be 10.2, and we have no units, so we don't have to worry about that part. Okay? If you have any questions, make sure you're asking in class.